and again it's to the 5th power. Instead of this combination, I'm going to go with my 1, 5, 10, 10, 5, 1, because it's so much easier to do that than having to go through all those combinations. We will have 1 times 3y squared to the 5th times negative 2 or negative z to the 0, so I won't write that, plus 5 times 3y squared to the 4th times negative z to the 1st plus 10 times, I'm going to need every inch I can get here, positive 3y squared to the 3rd times negative z squared plus 10 again times 3y squared quantity squared times negative z to the 3rd power plus 5 times 3y squared to the 1st times negative z to the 4th plus 1 times negative z to the 5th power. We would then need to evaluate all of that out, and that will give us 243 y to the 10th minus 405 y to the 8th z, watch your exponents there carefully, plus 270 y to the 6th z squared minus 90 y to the 4th z to the 3rd plus 15y squared z to the 4th minus finally z to the 5th. Okay, that's a very long expansion, and we don't always need every single term written out. Sometimes we only need to go and find the 5th term in that expansion, and that's where this formula for the kth term of a binomial expansion comes from. Basically, you know you're going to have your ascending and descending exponents. It's just a matter of getting the right binomial coefficient in front. So in this next problem, we have y cubed plus 2z squared to the 14th power, and we want the 10th term. Well, basically, this is going to be 14 on the top of our combination formula, and then we will have 10 minus 1 down below. This will be times y cubed to some power times 2z squared to some power. Well, the trick is, when you notice that down below 10 minus 1 is 9, that's going to match with 9 up above this second exponent, and these two exponents need to add up to 14, which means the first one is going to be a 5. This tells us we will have combination formula gives us 2002. We then have y cubed to the 15th power, which is y to the 15th. Y cubed to the 5th power is y to the 15th. We then have, after that, 512 z to the 18th power. Multiplying the 512 and the 2002 together gives us 1,025,024 y to the 15th z to the 18th. And this is pretty much pattern recognition here. Let's go to another problem. We have our binomial being raised to the 6th power, and this time we want the term containing a to the 9th. We know we will have 6 choose something. We also know we will have a cubed to some power and 4b in parentheses raised to some power. In order to have a to the 9th in our value, it's going to have to be a cubed getting cubed. And since we're going to have exponents adding up to 6, 3 plus 3 adds up to 6. And that value being 3 at the end means that we're going to have a 3 down below in our combination. So evaluating this combination, we get 20 times a to the 9th times 64b to the 3rd. And 20 times 64 is going to give us 1,280 a to the 9th b to the third. Find the indicated term. There it is.